Welcome to today's screencast or webcast about asynchronous architectures with CouchDB and CouchDB's changes feed. Let's see if we can advance slides here. Hey, so you see my name. My name is Jan Lehnert. If you want to ever Google me or whatever, do the internet stalking. Like Catherine said, if you have any questions, just pop them up in the chat room with a capital Q. But if you later sleep on what you just what you learned today, and then a question pops up later when the chat is all gone, you can still send me an email if you. I hope I can answer you in a good time. Then, if you want to follow me on Twitter, I'm at Jan L. Pretty easy. So I won't dwell too much on who I am, because it's boring. I'm one of the committers of CouchDB. I'm one of the authors of CouchDB Definitive Guide. Catherine said so much. There's a picture of me that is like 3 years old, and this is a current picture of me that's a couple of weeks old. I wear glasses. I don't usually wear glasses on the internet. I have more beard, shorter hair, whatever, and I have a funny t-shirt. Anyway, that's me. Let's go next. I hope I'm not boring you. So let's go for an introduction. So first, I'll give you a very brief, high-level overview of what the changes feed is and what it does. Then I'll go through the details of how technically you are using the changes feed and what options there are and what you can do with it, or the techie details you can do with it. And finally, I'll be talking about the bigger picture, the bigger architectures that you can build with that, and why they are a good idea, why it's a good idea to build them. All right. The general question that the changes feed for CouchDB can answer is what happened since. The scope of the changes feed is a single CouchDB database. CouchDB is a database management system. I guess you all know that. You can have multiple data in a single server, and each database has its own changes feed. And the changes feed is really a record of what happened in the database, and that can be used in multiple ways, inside and outside of CouchDB. That's what today is all about. So keep that in mind. The general question about that the changes feed can answer is what happened since, and I'll go into all the details of why and how that's good. So there's two more specializations to that. The one is what happened since the beginning of time. So every change that ever happened in the database is recorded here, sorta. But all the things you need to know that have changed in the database are recorded here, which is all you need to know for building practical applications. And then the other question is what happened since the last time you asked the changes feed, which is a little more fancy. So you can keep track of the results you get from the last time, and then you know, okay, I got all the answers up till now, and then you wait a bit, and then you can ask again what happened since the last time I queried the changes feed, which I think is pretty neat. You'll see how that works in a bit. All right. There's one technical detail that that I'll need to set you up with, which is kind of crucial. Whenever you change something in a CouchDB database, that means you create a new document, you delete a document, you update a document. Each single operation, A, gets recorded for the changes feed, and B, gets assigned a sequence ID. And there's for writing to a single database, there's only ever one write operation that can happen at any one time. So there's no two writes that go into the database at the same time. They're all serialized at the database level, and each write gets assigned a sequence ID, and it's just an monotonically increasing number, like an auto-increment number, but it's local to the database, and you can't do, well, you can do some fancy things with it, but you can't have them travel around the world. They're local to the database. So that's what they look like. I made up 71 for you, so you can look at them. it's really just integers and they go up. They start with 0, you write the first document and the sequence number is 1, you add another one 2, you delete the first, it gets, this change of deletion gets assigned the number 3 and so on. And each database carries with it the latest change, or the sequence number or sequence ID that is current for that database. I'm chuckling about the chat, I'm sorry. Another thing about the changes feed is, we'll get into more details later, is that is highly concurrent. That is a function of CouchDB being written in Erlang, and Erlang being really, really good at concurrency. So the gist here is that if you query, if you're a single user and query the changes feed, that is not a big deal. But the changes feed is also designed to be queried by hundreds and thousands and potentially tens of thousands of concurrent requests at the same time, and CouchDB happily supports that model. And we'll go into how these things look later. But it is meant to be queried a lot and in parallel. So that sets you up with that. And that is already like the high-level overview, and now I got into the tech details. This is probably half of today's webcast. Like I said, each database has a changes feed, and here we have a database called DB, and all you need to do is make an HTTP request to the database, and then a special URL called _changes. And when you make the request, CouchDB will will return all the changes that happen for that database. There's more to it, and I'll show that on the next slides, but what you want to take away from this slide is there's not much to making a request to the changes feed. And later, when you learn that the changes feed is really powerful, the basic principle is you just make a GET request, with like the thing that people have done, like the default operation on the web. It's the simplest thing ever. You just query or make a GET request to URL. So let's see. This is a listing here, and I'm trying to use the pointer to see if that works. So I have a CouchDB database that listens on localhost 5984. I have a database called DB, and I'm querying the changes. curl is a command line utility for making HTTP requests. If you don't know about curl, learn about curl. It's really, really cool. And what you can see in the in lines 2, 3, 4, and 5 is the result of that of this query, of this request. And what CouchDB returns is sort of a wrapping. Damn it! What has it done? I didn't plan to do that. Sorry. What CouchDB returns is sort of a wrapping JSON object. So what you see is there's a single member results, which is an array, and in our case is the empty database. There's no results in here, and then it also returns the last sequence. So you know that for next time. I already talked about that. So when we start out and the last sequence is 0, we have no results, and there's an empty line in here, which CouchDB actually literally returns, and we can totally visually see that there's nothing there. I hope that is kind of clear now. So behind the scenes, we're now creating a document. It's the simplest command ever. I don't show it to you, but we create a new document and then we make the same request again. So there's more stuff in here now. We do again. It's the same request, same host, port, database, changes URL, and we get the same results. Partial object first, and then where the blank line was before, we get another. We get a new line. It has a couple of members, sequence, SEQ. That's the sequence ID or sequence number for that change that just happened. And since it was 0 before, it is 1 now. Very simple. I created a document with the ID doc just to make it simpler for you. And we got you now know which document was changed. You don't know what kind of change it was. Like, okay, in this case, you know it was created, but I could also update a document and it would give me the ID here, but you wouldn't know that it was updated. Anyway, there's another member here called changes, and changes is itself an array of objects or a list of objects, and by default, all that's in there is the revision. When you create or update CouchDB documents, you create new revisions, as you probably heard or learned about CouchDB before. There's options to that query. I'll get to that later. To get conflicts and other information about a document, but by default only the revision object is inside this changes array. So this gives you all the information you need to then process or do whatever based on these changes. Maybe request the new document. And finally, the last sequence member is 1, of course, and that should be obvious. There's already a bunch of questions. I'll look at them quickly and answer them while we're here. I like answering questions in context because that's easier. So Sebastian Ohm writes, does CouchDB compaction create changes events? It does not. CouchDB compaction is completely transparent to the user. You'll never know when a database is compacting. The only visual changes that if you request database info once and it's a big number, like it has a lot of bytes in size, and then the next time you query it is less bytes in size, then you know it got compacted. But that's like, you usually don't question that. So there's no actual database activity. It's all under the level of database. So a compaction does not trigger events in the changes feed. Russell asks, does Couch only emit a single record for a unique doc? The sequence key is emitting 238 for me. One of those docs has a bunch of changes, so I'm assuming it's skipping the previous change and the most recent. That is correct. If it would change this document, I would get a new entry sequence 2 ID doc, and that would be the latest change to that doc, but it wouldn't show the sequence 1 row that we see here now. So it only shows the latest change for all documents. Tetsuo asks if the ref field is UUID based. The ref field is 2 parts. The first is an integer that is incremented for each change of the individual document, and then the second part is an MD5 hash of the content, the full contents of the document. So it's sort of like a, what's it called? The tree system that is used in Git, that each current checksum is based on the previous checksum. Right. And Jeffrey asks basically the same question that Russell asks, and anyway, we're good. I'll get back with the slides now. So I think that's good. And the details of how revisions work is really not the scope of this webcast. So I'll refer you to the book, which is, I'll link to that later. That's an online version of the book. Let's create. I know you haven't I talked all the time and behind your scenes. I created another document with the ID doc2, and now I do the same query that we did before, but with 2 documents. So now we see the result for 2 documents inside the inside the result for the changes feed. So you see the first one is here. Yeah, the system's lagging for me a little. So we have 2 rows in there. Right there it says doc, and a little lower it says doc2. And so we have 2 docs. It's very simple. Last sequence ID is 2, and that should be all obvious. Another side effect is I created the same, like the contents of the documents are the same. So you see the MD5 hash inside the ref is the same. Yeah. And this is like the default case. If you would keep adding stuff to the database, you would just get every change that ever happened to it. So this is answering the question: what happened since the beginning of time? But if you make 2 queries and there's 1,000 things that happened since when you asked, and you have 1,000 changes and you process them in whatever way, and then as a few more changes, say 1,005, and then you query again, you don't want to yourself go and discard all the 1,000 things you already cared for and just keep the second 5, or the last 5. And for this case, the changes feed accepts a query parameter. You can see that where I put the marker. It says since equals 1, and you just put in the integer of the sequence ID of the last change you know about. So we already know about the first change, and now the result only includes the second change. Very simple. That is, just keep that in mind. Oops, I skipped too far. Another thing that's very convenient, and you might know that from how views work, it's the include docs option. You can see that here. We're using the same query with since equals 1, but we also add include docs equals true. And what that does is, before returning the result row for that particular document, it also fetches the real actual document from the database. So your result gets augmented a little, and before you didn't have this third member doc here, as you can see where the marker is, but this includes a full copy of the document, and you don't know that. I created an empty document, no fields in it, and it only has the two fields inside the document that come with CouchDB. It's underscore ID, and it's doc2, and underscore ref, and it's the revision. If I would have put more data inside the document, it would show up here, right here. So dig, you ask the question if since equals n option corresponds to the last sec field in the JSON you got, and that is totally correct. So for the next time, we're keeping the last sequence 2 in mind. We just store that locally. I put it in my brain, and on the next slide we use that. John David asks if it also includes the docs attachment. It does not. The thing with attachments is that they might be binary, and decoding the binary into the JSON is really not a good idea. It will include the stubs for the attachment, so you will have an attachments member, and you will know that there are attachments and what their names are, and then you can fetch the attachments separately. But the attachments themselves, the attachment data is not in there, but all you need to know about fetching the attachment data is in the result. Cool. This is fun. There's different modes to this feed. Right now, what we saw is we make a request, we get a list of everything, and that's it. And that is the default mode. In total, there are 3 modes. The first one is polling, and that's just one of the most simple ways to ask if there's something new. Just ask the server, is there something new? And the server says no, or it says yes, here's everything I've ever had. You decide if there's something new. It's also a very dumb case, but it works for the first request you make. That's always useful, but for later requests you might want to be smarter, say with the since parameter. But we can do even better. The next up feed mode is long polling. That is for older browsers needed that. It's kind of cool. So we do the same query as before. We still do since equals 1 to get one result, and we don't create new documents so far. We do include docs, and then we add feed equals long poll. And the feed option takes the default is poll. We're looking at long poll here, and what this does now looks exactly like the previous result we've seen. So I'll put in some more information in this listing. I'll go to the next one here. I put in timing. So what this does is, now remember the last sequence we had previously was the since 2. Now was 2, so I put it in the since parameter here. So it's since 2. Otherwise, it's all the same query. And I put timing in here. So 0 minutes 0 seconds. We start the command, and then it's 0 minutes 0 seconds. The header of the result comes back. Thing that always returns. So we have a valid JSON object. And a list. And then for 10 seconds nothing happens. This is me. I'm going to open another terminal window. I'm creating a new document with the ID of doc3. This subsequently creates a sequence 3, and that all gets returned. That gets shipped through our query, and then CouchDB sends also the closing array or the closing list bracket and the rest of our result document here. And then our request is done and it's gone. and that's kind of neat because you don't have to. You can just open you just open an HTTP socket or a TCP socket over HTTP, and then just wait for any change that comes in. So, and both you, the client, and CouchDB will just sit there and wait until something happens, and if nothing happens, it just stays open. There is like a tiny side effect of that. I didn't put it in the slides, but you can read all about it in the book. Is sometimes networks are tricky, and you as a client can't distinguish between there's no changes coming and there's the network is down, but I don't detect it because I don't get anything set. So there's another option you can put in there, which is called heartbeat, and then a number of milliseconds, and maybe put in 1,000 there. So you get a new line character every second or every 10 seconds or whatever you need, like granularity you need. So you know whenever you get a new line character, you can just discard it when reading, but you know the CouchDB is still alive and the connection is good. But there's no results, and then if there's no more new lines coming, you know the network is down, and you need to do a new request. Alright, I'll get into that question later. I'll just that gets answered later in the screencast. So thanks, Norman, though. But the gold standard of feed mode is continuous. That's the one I like most. It's the best one. That's what it says on the slide right here. It's best. Doesn't mean you should always use it, but it's still pretty cool. It's a little semantically different from the other ones, but like it also has like a lot of O's and U's, and so in it I like it. It's really cool. That was me trying to be funny. Anyway, this is what continuous looks like. So we update the sins to 3. So because we don't care about the older stuff, and we say feed equals continuous. So it just goes on and on and on. And I put in the timing again, and like it always takes me 10 seconds to create a new document. I have no idea why. It's really slow. I'm really clumsy and don't know how to use my terminal history. So you know, we just sit there, and after 10 seconds, I create a new document called doc4, which is here. It creates the sequence 4. And then after another 10 seconds, or after 20 seconds total, I create another doc called doc5 with the sequence 5. And then it just goes on and on. So continuous opens a socket between the client and CouchDB that they will hold open forever. Forever being until CouchDB maybe terminates it on its own, but it doesn't by default, or it doesn't do that. The other is you can terminate the request and just close the socket and don't query anymore, or the network breaks up in some way. And you can also use all the heartbeat parameter here to distinguish between no results and dead network, which is kind of nice. But to make this curl request here return, you need to like Control-C the curl. It won't ever stop. You know, like if you do that on localhost, there's no reason CouchDB or curl die at some point, and then it just stays open forever. So yeah, forever. It's cool. And whenever something, now what you see here, which is different from the previous one, is the first thing that gets sent just happens after only happens after 10 seconds. Previously, we had at the 0 second we had the header of the results object, and after we get all the results, we had a footer of the last sequence number. We don't do that for continuous changes, and you also see that it's not a JSON list, but it's single objects per line. You can't really see that it's on one line, but it's all meant to be on one line. So this is to make parsing a little easier. So you get just a complete, a new line determinate list of JSON objects, and you just like, okay, I get a new line, everything that's between this new line and the next new line, I can just throw into a JSON parser, and there's my object. Really, really simple. So whereas with the other results, they first complete a full JSON object before you can decode it. So we made this to be a little bit better to use. Alright, that's fun. So if you were a crowd, I could see, I would like ask a show of hands who here likes replication, or not replication, the changes feed so far, and I hope you would all raise your hands. Is there a default timeout on continuous, or is it just a curl feature? I think there is a default HTTP timeout somewhere, but I'm not sure. you can if you figure out that your infrastructure, and maybe there's some like transparent proxy in there you don't know, like mobile carriers do that a lot, or mobile operators do that a lot, that has a timeout that is neither set on your client or your server. You just need to find out and then set the heartbeat rate to lower than the timeout, and there's always stuff that comes over. Yeah, Russell says there might be default timeout inside curve was 30 or 60 seconds, but I don't think HTTP has a default timeout. Like these connections can hang in there forever for all the version like values of forever. So I got a bit of the crowd, like show of hands crowd to like the changes feed, which is cool. But it gets better. Dun 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 dun. But let me take a sip first. I'll mute my mic so I can take a sip. I can drink some water. I'll be back in like 3 seconds. And I'm back again. So filters. Filters are pretty cool. They let you, well, you have the changes feed that you already know, and then you can also have a JavaScript function inspect each document that is the cause of the creation of that changes result row, and see if you actually want that returned or not. So here's how a filter function looks like. It's a bit of JavaScript. Like, don't be afraid. It's just JavaScript. It's just effectively 3 lines of code. It's a function that takes a document as an argument and the current request as an argument, and CouchDB takes care of that for you. So, and now say we're only interested in documents that have a priority that is high. So we just make like an if statement. If doc.priority equals high, we return true, and if that doesn't happen, we return false. So the filter function is expected to return a Boolean value, true or false. Philip, don't be afraid. JavaScript is really cool. And then if you do a query, you can see that further down in the comment. If you say filter equals design doc, which is a name, and filter name with the name, then you only get the rows from the changes feed where this function evaluates or returns a true value, which is kind of cool. So if you have a widget on the website or wherever, if you're only interested in high priority stuff, you can just ask CouchDB to give you the high priority stuff, and that's more efficient than asking CouchDB for everything and then throwing away all the ones you're not interested in. Yet Fred, I could make that a lot easier and simpler, but this is easier. This is conceptually simpler to see. So yeah, if I would write it, it was just return dot priority equals high, and then that's that. But like if I put a like explicit if statement in there, it's like I like it better. I hope that's cool for you. There's a few more things you can do with the filter. The filter with parameter. So if we were to have different priority levels, you would have to, with the first one, you would create a document priority is high, is low, is whatever, and if you could subscribe to different, say, streams of prioritized documents. But you can also do just a single filter function and then make it add a parameter to the query. So we have a new variable here that we call priority, and the request object is just an HTTP request object. That's why it's called request object, pretty obvious. And it has a member called query, which is an object that's just a key value hash of the queries that you send over with the HTTP request. And that's the priority one we're interested in. And if you look at the how to query it, you see priority equals high. That's the one we're interested in. So if we now look that the doc priority is the same one that we're interested in, we get returned true. So you can, with the same filter, you can request or say I'm interested in all the high priority documents. I'm more interested in the low priority, and the no priority, or whatever else priority documents, without having to code all these different documents. Now there is, yeah, you all like filters. I love it. So the next part is, what about if you want to do a little bit of security? Like, how do I make it that I'm only interested, like I only get the documents I'm supposed to see if there's a document, if there's a database that has a shared set of documents. And we could do the same thing. Let's make if document name equals and then the query parameter name. So I could take would do the query with the name equals Jan, and then would only get the documents that are that have my name in it. But that wouldn't really like secure the system in a way that I could put in Joe and I would get all Joe's documents. That would be pretty lame, right? There's another way to do that, and it's on the next slide. It's filtered with security. Inside the request object that gets passed into the function, there is a parameter called user context, and the user context holds a username, or holds a few informations about the user that made the request. So with HTTP, there's different ways to authenticate. There's basic auth, there's cookie auth. CouchDB supports OAuth, and it's also very pluggable, so you can put in other authentication schemes. But the thing you know is, if request.usercontext.name exists, a user put in his correct name and password and authenticated successfully to the CouchDB server. So only if that name is actually set, I also know that that person is really the person that they claim, which is kind of nice. And in that case, we return true. So just give me all the documents that have my name on it. And the query is just the default query and whatever authentication scheme you have. The question. Filter looks like map is the reduce. Map is a bit like, it looks very similar. A map function doesn't have access to the request object because there's really no request during map function. Also, the map function calls an emit function to populate its result, while the filter function must return true or false. So it's not the same, just looks a bit similar, and there is no reduce. Doesn't make any sense here. But excellent question, because they do look similar. I find myself looking at map functions and wonder why they don't work, and then I'm actually looking at the filter function. John David asked, do we have access to users' roles in the user context object? Yes, we do. So there's also a concept of roles inside the CouchDB authentication system, and you have access to that as well. Nuno, is there a page where I can go to read about all the features that I'm describing here? Yes, there's the CouchDB book guide.couchdb.org. I'll have the link later, and it got posted earlier. Also, hi Nuno. Right, I'll go on with the presentation. I'm not even halfway through here. So let's see, next slide. Okay, so this, well, we won't dwell on this a little. I may not dwell, but do you have any more questions on the technical side of like how the code or how the requests look like? Just pop that up, because after this I'll talk about the bigger architectures. You can build with that. I'm waiting for a second. I'll take the opportunity to take a sip again, and I'll be offline for 3 seconds. That was 5 seconds. I also took a deep breath. This is quite fun. So I guess there's no more questions right now on the technical part, so I'll move on. The first thing to build with that is the example of an external indexer. CouchDB ships by default with a view engine that lets you do map and reduce queries over your data, which is really, really nice, and it really does solve a lot of problems that you have building websites, or not just building websites, building any projects. But it isn't perfect for everything, and that's why there's other indexers, and CouchDB is built in a way that you can just plug in new indexers. And the changes feed is one of the parts that we built to put into the external to build an external indexer. The two ones that are most widespread is CouchDB-Lucene for full text indexing, and GeoCouch, an extension to do geospatial queries. Daniel, you're asking about the the free online docs. The book is free and online. You can just read it on the website. It's awesome that O'Reilly lets us publish that under a Creative Commons license. So just click that link after the screencast. You can just read all about it. Cool. So next part. So that is interesting. So I submitted my PDF, and it made it lost a few things. Let's know. Do not despair. Looks a bit funny. So what we have here is an instance of CouchDB, and all we have on the right is an external indexer, for example geo, couch, or a full text index. Somebody built a SQLite index, so you could run SQL queries on top of CouchDB, which I thought is really cool. I love this picture, how that turned out. There's a few. There's that, and there's CouchDB users. I put in a cloud here because everybody loves clouds. So you can. This is just everybody who query, like your application that queries CouchDB. It's over here. I know it's all very slow here, so I can't really point to things. So this is where the users talk to CouchDB, and here's how the general architecture is. The indexer just subscribes to the changes feed of a CouchDB database that it is told to index. First step. And then as changes come down into the indexer, like the indexer gets notified, here's a new document that you might want to index. Here's a new document you might want to index. The indexer can either ask, or you can specify the include docs query, so things get sent over with the change, but that's just one document at a time, and that might not be optimal. The usual second part is the external indexer just like waits for, I don't know, 30 seconds. I think that's the default in CouchDB-Lucene, or was at a time. So it can it collects all the documents that change in 30 seconds, and then asks the regular CouchDB REST API that's here, the same that all the users are using. Just give me give me all the objects that changed earlier. And then it integrates that into that index. And now, what I didn't put into the picture here, or it got lost, is that users can also make requests to CouchDB that get redirected to the actual external indexer. So to basically create new URLs. So you can make a query to that index that is piped through CouchDB instead of just having to go a separate route or anything. The next part is, so I see Philippe Rocha has choppy sound. Try reloading the web page or restarting the Adobe thing. That's what people say helps. So it doesn't matter what external indexer you have. You just listen for changes and then integrate these changes, and then there's also a hook to get requests forward. This is, I think, pretty simple, but it's very nice. And Robert Newson did a great job at with creating CouchDB-Lucene, and Paul Commission did for GeoCouch that all use that. And there's two links that you can click to go to check out the source code of CouchDB-Lucene. Beware, it's Java, or Volker's CouchDB fork that does GeoCouch, and beware, it's Erlang. Whatever floats your boat, but these are the two things we're using. So yeah, that's mostly meant for posterity, so you can find the other ones. The next feature I want to show you that the changes feed does. It powers an internal feature of CouchDB called the CouchDB replication. And here's this picture turned out better. It's kind of nice. So replication works in a way that you have two databases, and now we have CouchDB A and CouchDB B. And we can make a request, in this case a post request, to /_replicate, and we send a JSON object with a source and a target. In this case it's just like string here, but it can also be a URL. So and then CouchDB goes and replicates everything over from A to B. But it is also smart, and that is when you do that again, it only submits the changes from A to B. And so this is what you see in the comments. On the first run, it detects that there's no prior information about replicating from A to B, or from DBA to DBB. So the since parameter gets set to 0 because all the changes that are on A need to go over to B. and then it stores the last sequence ID that is in that result. And then whenever it stores that under in a private document inside itself that includes the source and the target. And whenever you do the replication again, CouchDB detects, hey, we had a previous replication here, and the last sequence ID, I already have a last sequence ID, so I can use it with a since parameter, which is kind of nice. So I only I can only send over the things that the CouchDB doesn't know about yet. Same procedure basically as earlier, but very cool. I don't have a slide for that, but replication also supports continuous feature. So you can just say replicate everything, and then whenever something new comes in, keep replicating. You just put in here replicate :true, just very simple, and it just does that, and that is no replicate true, continuous true, and that by the name you can tell it uses the continuous changes feed. Very simple. Question about the name of the SQL interface. It's somewhere on GitHub. I don't know. Can't remember. Has been around. It took like it was a very rough demo. It was a year ago or something. You can also do custom replication, and you can probably get where this goes to, because the primitives that we went through are pretty simple. It's the same deal that regular replication is, except that the target is in the CouchDB. So what? Oh, I have an example for that, which actually isn't an example for that. It's the other way around. So Michael Rogers wrote this thing called TweetStream, which is actually the other way around, where the source isn't replication, but the target is. Well, what's CouchDB? What TweetStream does is, and Twitter has similar features, like give me all the tweets that are relevant for me, maybe search query or my name or whatever, since the last time I asked you, and that's the same principle that CouchDB uses, because it's a smart principle, at least CouchDB and Twitter agree. And then it stores all the tweets about, say, search query. So if I want to know all the tweets about CouchDB, I'll make a search request to Twitter, and I keep asking them to give me new stuff, and then I store which the last one was that I got, and then they can give me only the ones that I'm interested in. So that is actually a counter, like the opposite example of what I said on the slide, that the target isn't CouchDB, but the source isn't CouchDB. But the other way around works just like that. So you can update other things outside of CouchDB incrementally. That was my coworker, if you heard that. Anyway, it's written in Node.js, which is kind of nice, and I want to give a little shout out to Node.js. CouchDB changes, and Node.js is really a match made in heaven. Node.js, if you don't know it, it's an invented framework to write server-side JavaScript, and since the changes feed is also evented, there's events that come in whenever something happens inside CouchDB that the client doesn't know about. It sends you a new object or new row, and then in Node.js you can just run a JavaScript function and do whatever with it. And Michael has some code on his GitHub repository to do that. So it is really, like, if you were looking to build stuff that are external of CouchDB, one of the easiest things to get going with is Node.js. Except you don't like JavaScript, but why wouldn't you like JavaScript? There's a bunch of more things I want to show you. The next one, real-time chat, and should be another picture here. Hey, and it's not botched. That's pretty cool. Yeah, there's more people doing cool Node stuff with CouchDB that are in their respective GitHubs. I don't know all of them. I can't remember all of them. Another question. I'll go through the questions really quick. Another one is 0.11.1. 0.11.1 should have continuous replication, so you don't need a cron job for that. So you just make a single request, and that works. So real-time chat, yay! So we have a database here. Let's see. I would love to use the pointer, but this Adobe thing is so slow. We have our database here, and a bunch of users. There's user A, and there's another user A. That's meant to be user B, of course, and the colons here say, oh, there should be more users. So like, just think there's an infinite number of users, which gets back to the previous point of you can have really any number of users listening to a changes feed. And the basic idea is we create a new message in our database, or new document in a database, which is a chat message, and then each client is subscribed to the changes feed and gets sent this message. And if you want to reply to that, you just kind of post a document or another message to the database. Yeah, right. There's a project called Toast by Chris who wrote just that, and I'll show you code out of Toast in a minute. I really wish this thing wouldn't lag so badly, so I can point you to things. So whenever, say here, a user posts a new document into the database, both this and this changes feed will send a line to the appropriate user, and again the lower user is B and not A. And that means everybody gets the message right away, which is kind of neat. Now I'm still waiting for my cursor. I really like bitching about this tool. Here, if you know jQuery, or if you don't know jQuery, it doesn't matter really. This is just what it takes to listen to the changes feed inside jQuery. You first need an XHR object. You need some low-level stuff, though you can't use the higher-up abstractions for it, but it's still really simple. It's just a native XHR object, and then you make an open request, or use the open method. Oh, damn it! Sorry. Use the open method here, and send it a GET request. Again, simple as pie. There's a URL here. I want the DB. The changes a continuous feed since the last update sequence that comes from somewhere else, and I want it to be asynchronous. And then I send a request. And I also set up the onReadyState change, what a mouthful, event. So whenever I get a result, something sent back from that request, this function gets called, and that's why I know to look for new data to put into my for new data that is in the chat room, and update my UI accordingly. So this is really, a chat is always a sender and receiver and some display logic, and this is all it needs for the receiver. It just where it's green, it says callback for new changes, is where you update the display. It's really nice. Next part, you can use the regular.ajax request here from jQuery. Posting a new message, I'm faking here and just create one called with the text "Hey there" and turn it into JSON. I have a database chat. Earlier we used DB. We go with chat now. I'm just using a post request, put in the message, set the data type, and when that function returns, or when that request returns, I clear my message form, so the user gets an indication of his message getting sent. But because he's also, from the previous slide, subscribed to the changes feed of the database, he gets an update, and his UI updates accordingly and independently, most importantly, independently of creating this document. And everybody else's changes feed also gets triggered, and they all also get an updated UI. And this decoupling, this independence, is an important part to keep in mind. We'll get to that in a bit. So that was a bit of code, but I hope that's all clear. I'll quickly see if there's questions about that. Right. So yeah, Chris did a webinar on Couch apps. You can go to YouTube, Google for O'Reilly CouchDB, and you see all the screencasts we did. So let's see. Yeah, Michael, I think that's what I said, but it doesn't matter with the XHR. And does onReadyState change gets called with the new lines output? Yep, they do. And so if you do that for real, then you need to handle that as well. So I omitted some of the code. And yeah, the Evently screencast is where you learn about how to build Couch apps. So let's go on with the messaging example. It's a bit Twittery, but it doesn't have to be Twitter, because I don't actually know how Twitter works internally, so I couldn't comment on it. But this is how I would I would start my own small Twitter. And this got botched a little as well. So just imagine there's these boxes here with the arrows. You can see that here, that are actually here, and that the arrows are between these two boxes. You can still see the end of the arrow pointing to that box. Just sorry about that. Still looks funny. I probably should open an art exhibition or something. So you all know what that means. We have a database per user, and we call these database an inbox. And I want to send people inbox. Yes, we'll put up the PDF later, and it will not be broken. And to deliver a message from user B, which is here, to user A, which is here, all that needs to happen is that user B creates a new document in the inbox database of user A, and then that is the sending of the message. And what user A now can do is to use one of the long poll continuous change requests to see if there's new messages. In the default case, we all know that from before Gmail or other crappy webmails, there's a refresh button, or you refresh your browser, or if you're on Twitter, or whatever. I don't do Facebook, but maybe you do the refresh on Facebook as well, or used to, until they figured out, like, most of the time there's nothing new, and sending all the full HTML for all the pages is really expensive if you do it at large scale. So we should do smarter, and so. The first iteration of that was using long polling. Just open a connection to the database from the user to the inbox, and then whenever a new request comes in, I know, oh, there's a new message, or a new result comes in, there's a new message, and user A needs to run some logic to update its page, or the local representation of that inbox. But that's also, and then make a new request, and that's again a lot of requests, and at some point making requests becomes really expensive too. So the iteration from that is using the continuous mode, and we have a bunch of applications on GitHub, mostly written from jQuery so far, and Toast and Focus, that use this, and Wiki that use this continuous feed, where you just connect widgets of HTML and eventually does that from the database here to the user A, and then whenever a new message comes in, the user just automatically gets a new message, and he doesn't have to do, or she doesn't have to do any more separate requests. And that's pretty much the optimal way, like doing push notifications instead of polling. Well, the most efficient way to update a user. Yeah, WebSockets are interesting. I wish they would finally finish standardizing them so we can implement them. Also, they are a bit weird, but whatever. We'll find out about that soon, I guess. So this is the basic messaging part. If you want sending a message is reduced to creating a document in a different database. And then the neat part of that is it's asynchronous, and we again have these things of there's the sending of a message is decoupled from seeing if there's new messages. Like if you were building things in PHP MySQL, you would probably couple these things. I don't know. So they are asynchronous. They do scale, which means having thousands and thousands of changes requests open for a single CouchDB is again no problem, and it's really really fast. Like if you would build, we did the chat thing, and we have a bunch of couches connected using continuous replication, and we also use the changes feed to update our UIs, and then a message could wander through 3-4 couches, and it's still that are all connected through the internet. And it still feels like real time. There's no lag in there. It's really really quick. Next part. Backend logic and multi-document validations. That sounds super fancy. So yeah, what CouchDB encourages you to do is keeping the request response cycle very very lean, and you can also always only operate on a single document at a time. And if you want to say, okay, I wanna create a new user document and a message document, and then when the message gets sent, I need to know if a valid user document exists for it. Core CouchDB doesn't do that. Clement, okay, I'll get back to that, to the compatibility in a second. Anna, if you would please put that on the questions thing for me. But luckily, we can build an asynchronous architecture for that, which is what we're here for. Say we're the general state is the user creates a new document, and it's we just by definition say, or by convention we say state equals new, or state is new. And then there's an external process that uses the changes feed. It may be a filter that filters for the new state, and then does some processing with it, but so that maybe there's multiple worker processes here, so that no other one takes it over. It changes the state to in process, so no longer shows up in new. And then the external process can do whatever with the information that's inside that document, and I'll give a few examples in a bit. And when it's done, it just sets the state to done, and then you know that process has been done. And the external process could also make queries to CouchDB again and get more information to make sure I can actually successfully set the state to done. It also could set the state to error and then give an error, and then the application itself could then look again, okay, this thing has an error, user, what do you want to do with it? Like, I couldn't send this email, for example. Again, this builds asynchronous architectures, which is nice because you don't couple things with each other. There's independent actors doing stuff, which is really nice conceptually, and it's all small parts. Like you have the CouchDB part, and then there's the external handler that does this one job, but does that very well. And that makes things a lot easier. Next part. Alright, the general idea of external, I just explained the general idea of external services here, but one could be sending email, and it's the same schematic here. We create a new email with the state outbox. That means, okay, we just created one, and it sits in the outbox and it's waiting for delivery, and it's also an email. So we have an external process that can send email, that has an SMTP client in there. And then it would do a filtered changes request to the database this is in, and it would filter for outbox and email, and then again set the state to sending, because it says I want to send this now, and again if there's multiple ones, only one can only ever send it. And then it does its work, and later when it's done, it sets the state to send. And now these states can also be used in the user interface to make a query, make a view of all those sent emails. You just look for state equals sent, and you won't get any of the ones that are sending or outbox because the state's different. That is using a document as a state machine. So this again lets you, we try to get all of you to build all your web applications on top of CouchDB, and there's a few things that CouchDB doesn't do, like sending email, but we give you all the hooks to build that, and there's a few of these services around already that you can use. Some of them use Node, some of them use Python or Ruby, but the language actually doesn't matter that you can use that with. The sending email is just a general thing that is asynchronous, that has maybe separate error modes that are not really relevant to the request-response cycle of the user interface. So if you have, say, a Rails app that sends email, you say send email, and then that creates a new record in the database, and then it also opens an SMTP connection and then waits for the server to respond, and it sends the email, maybe it has an attachment, and it takes a while, and then that request already took 10 seconds, and the user is like, Jesus, I want to go to my inbox and keep working. So what you would really do in a Rails app is create a separate process that would do that asynchronously, and that's what everybody really should do. And building these kinds of systems is really easy with CouchDB and the changes feed as well. Other example of that is resizing files. So you accept file uploads, and then there's images in there, and you want small thumbnails of that. You can do that as well. There's Felix from Node actually has Transloaded, which is a web service that does it. So you don't even have to implement it yourself. You just hook it up with the changes feed, and that service is pretty cool. You could, if it's messaging, you could filter spam, and whatever else lengthy asynchronous process you want to do, you can do there. You just put in, you're all smart, so you can just you think about, you find out. about that. So this is the general everything about that. The different architectures you can build with it. Right, Michael. The file uploads, good case. Exactly. That's what I mean by like file resizing, or like image resizing. You have a file upload, or maybe it's like whatever file, and the first thing you do, you just like maybe you only accept images, but you can't really tell if somebody tries to give an executable or whatever. And then you can do like some security analysis of that file first, but before processing it. And then you see, okay, it's really an image, and you can send it to ImageMagick to resize. And then once that's done, your user interface, by like the external process that does the resizing, updates the document to like it's now resized, or the thumbnail is available, and then the user interface can just pick that up and use it when it's ready, and doesn't have to wait around and leave the user waiting for whatever happens. There's 2 questions about compatibility with browsers. I think that goes back to the jQuery changes thing, and yeah, I think old versions of IE still require long polling, but even like all the latest browsers support continuous HTTP connections, which is kind of cool. Somebody was asking, wasn't looking at the latest version of CouchDB, but does CouchDB still need read-write access to the etc files? CouchDB does need, so when you start this is a separate question, doesn't have to do much with it. That is actually a function of your distribution. CouchDB needs write access to a ini file, but it doesn't have to sit in /etc. So that is about that. Clemens is asking about mobile browsers. I know about the iPhone and the Android browser, and they both support it. It's kind of nice. How do you recommend combining combining a Couch app hosted on something like couch1.com with changes feed works? I've been trying to figure out a good approach for that. For instance, trying to job queue change feed. Background, it's kind of awkward to set up a server just as a work queue. Yeah, this would be a perfect thing to set up as a service. So I work on couch1.com, and we totally have that on our we want to do that at some point, but we don't have that on the immediate timeline. So what you still need to do is set up a separate server, but somebody could step in. Okay, I have a server here that you can all run your Node.js on. Heroku. Could use Heroku for that, for example, and then just translate between your changes feed and say transload it. That I saw is mentioned in the chat room as well, to do the actual work. So yeah, this is generally where we want to move to, but we're not just there yet. But all the pieces are in place. So while it'd be great if it would be already available for as an application developer, you don't really care where your image gets resized, and if I would have a working solution, well, we don't have that just yet. But again, you just learn how all these can be built. So if you want to step up and make a generic service, people would pay for it. I'll tell you. Alright. Next question is, can one use GeoCouch as a filter? Query for changes in documents that fall inside a bounding box? That is not possible. What you will be able to do with GeoCouch is intersect, give me a view query and intersect that with a GeoCouch query, but on top of that, not do the filtering. That's so. With that, you still get pretty much all the things you need, because you can, you can subscribe to the changes feed, and then a document gets inserted into CouchDB, but you don't exactly know how it affects the query, the view and the CouchDB, the GeoCouch query. So whenever you just get the notification something changed, and then you just query the view again and see I know there's a change. Does this change affect your result? And then you can show it or not. So filtering, no, but you can still get around that. If there's more questions, I'll get into that happily. I'll round up. You saw the URL already. This is also for posterity. This is our book. You can buy it if you like, but you can also read it online. The cool thing about it, and we launched that 2 days ago. All the source code for that book is available on GitHub. You can just go to github.com/O'Reilly/CouchDBGuide, and it's also, the link is also on this link here, and you can just fork the whole book and then help us improving it or translating it. There's explain how that works, and every year or every how many months they want, O'Reilly can or will go in and make a new edition of the book with the help of the open source community. Philip asks, is the online version of the book not the final revision? It is. We have 2 revisions online right now on guide.couchdb.org. It's the draft, which is the one we are working on for the 2nd edition, but it's also the 1st edition is fully available on the website. For a while it was a little bit outdated, but again, since of 2 days ago, it's the latest stuff on there. Fanda asks if there's more documentation for index scanning than the CouchDB-Lucene thing. That depends on what index you want to build. So if all I know about the full text about that particular indexer is on there. Annie asks some URLs of commercial sites that use CouchDB. Anna, that's one for you. You can point to the case studies that we have for CouchDB, and there's also the CouchDB in the wild wiki page on the CouchDB wiki that I hope somebody can figure out for us. That has just a list of everybody who's using CouchDB, which is pretty cool. And if you still want to know more, please just get in touch. Right, there's the case studies we put up. It's just a few high-profile ones that we like, but they're already pretty cool. And if you want to know more, my email address in the slides, so you can just get there. And yeah, the BBC and Meebo are definitely ones we're most proud of. So Fenda, yeah, about the full text search, the CouchDB-Lucene, or a guy called Robert Newson, yeah, the same name that's in the link, is on the CouchDB IRC channel on Freenode. He's very approachable, and you can just talk to him about all the full text indexing he's doing. He built CouchDB-Lucene, and he's very friendly about helping people out. So yeah, I'll get back to the book. We would appreciate if you buy a copy. I have to say that because it's an O'Reilly thing. No, we really like that you buy a copy, but we also like you to help us out work on the next version of it. There's also a Couch Camp. We talked about that a little. It's in a few weeks, in early September. It's an actual summer camp and small CouchDB conference that we put aside for you. You can just go to couch.io/couchcamp and sign up for it. Hope to see you there, or you see that Justin's coming, and I know Anna's there, and maybe Nuno, I don't know. So a few of you will be there, and I'm looking forward to meet you there. And Couch Camp is going to be really fun. Last but not least, we're hiring. If you like what you saw and maybe are interested in working on this, go to couch.io/jobs. That's where the current open positions that we have. And that's so far from me. Let's say thank you. That's another question from Russell. Good open source example of doing changes feed state machine, basically proof of concept was talked about in this webcast. Russell, yeah, go to github.com/Michael, M-I-K-E-A-L. He has a ton of code that uses that. Also, Jason, github.com/JHS, Jason Smith, who built our hosting infrastructure. He should have some code in there as well. That actually uses that. I think I answered all the questions so far. I'll hang around for a few more minutes, show you a blank page here, to see if there's more questions. But if there's not, feel free to hang out on the CouchDB IRC channel, and feel free to send me any emails, follow-up emails, and if any more questions. And I hope you enjoyed it. And it's starting to get dark here in Berlin, and I'm happy to go to dinner in a bit. So again, thanks all for coming. It was really fun. I like doing these. I hope I can do it again soon. And yeah, see you.
Hey, thanks, Jan. That was great, as always. Exactly what I expected. And I do hope you'll do another one. We don't have the next one scheduled, so we should be talking about that. And I also want to thank everyone who was here today. Made it a great webcast. Thank you, everyone. And should I leave the chat room open for a few minutes, or should we go ahead and close this out and let you take up this conversation on the IRC channel?
Let's go to IRC.
Okay. All right, so I'm just going to count to 10 silently and then close out the room. Oh, September 2nd. Thanks, Anna. All right. Thanks, everyone. Bye-bye.